Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. In the previous video, we have seen how to find the inverse matrix of the multiplicative inverse of a 2 by 2 matrix. Now, what about if the matrix is square matrix but more than 2 by 2? 3 by 3, 4 by 4, 5 by 5, whatever. How to find the inverse of such matrices? Well, there is an easy procedure. And this procedure is as follows. We write the matrix A, vertical bar, the matrix in one matrix. So for example, find the multiplicative inverse of this matrix. So the first step would be to write the matrix A then a vertical bar, and then write the identity matrix. This is 3 by 3, so I3, which is 1, 0, 0, 0, 1, 0. If you don't know the definition of the identity matrix, check the previous video, please, about section 9.4. So we write it like this. Then what to do? Okay. Now we use row operations. Do you remember row operations in section 9.1? To obtain matrix of this form. So we change A to the identity matrix, similar to Gauss and Jordan elimination method. Okay. So we work with this matrix, matrix A, and change it to the identity matrix. What does it mean? This number has to be 1, these zeros, then this is 1, and these two zeros, then this is 1, and these two zeros. The same method exactly of Gauss and Jordan. So let us do that. So this number is 1, that's good. This is 0, that's good. I need negative 2 to be 0. I'll use this one. So 2R1 plus R3. Of course, when you do this operation, you do this operation for row 3. It will change all of row 3. Okay, so I have 0, 0, I have 0, 0 here. So these two columns will not change because of this 0, 0. When you multiply 2 times R1, if you have zeros, nothing will happen to these numbers because 2 times 0 is 0 plus 1 is 1. All right. But for the others, there will be a change. Of course, the second row is not changing. We are not doing anything in it. Now, 2 times 1 is 2 plus negative 2 is 0. 2 times negative 2 is negative 2 plus negative 3 is negative 5. 2 times 1 is 2 plus 0. 2 times 1 is 2 plus 0. So now we finished from column 1. If you have any problem with row operations, please check back section 9.1. All right, now this negative 2 has to be 1. So let us divide R2 by negative 2 or multiply R2 by 1 over negative 2. So the first row as it is. The second row now, negative 2 over negative 2 is 1. Here 1 over negative 2. Here 0. Here 1 over negative 2. And here 0. And row 3 as it is. You notice that while we are changing the matrix A to the identity matrix, also this matrix to the left is changing. And once we reach I here, B here would be A inverse. So that's the very easy method to find the inverse. All right. Now I have to use this one, the one in the middle, to make negative 1 and negative 5 zeros. So how to make negative 1 0? R2 plus R1 and 5 R2 plus R3. R2 is not changing. And R2, I'm using R2 for changing. So There is a 0 here, so this column is not changing. There is a 0 here, so this column is not changing. There is a 0 here, so this column is not changing. Okay, R2 plus R1. 1 plus negative 1 is 0. Negative half plus 1 is half. Negative half plus 0 is negative half. 5R2 plus R3. 5 1 plus negative 5 is 0. 5 times negative half, negative 5 over 2 plus 4 over 2, this is negative half. Negative 5 over 2 plus 0, this is negative 5 over 2. So this is the new matrix. Now I finished column 1 and column 2. Now this negative half has to be 1. So I multiply R3 by negative 2. There is no change right now in these two rows. Now 0, 0. Negative half times negative 2 is 1. Negative 2 times 2 is negative 4. Negative 2 times negative 5 over 2 is 5. And negative 2. So now I have 1 here, and I need to use it to make these two numbers zeros. So how? This is negative half. So half R3 plus R2. And this is half. So negative half R3 plus R1. And this is the final step now. And I will have the identity matrix now here instead of A. So I will have 1, I have 0, 1, 0, 0. Let me write first row 3. Now row 3 here, we are using row 3 to make zeros. So row 3 is not changing, and any 0 in row 3, the column remains the same. All right. Half plus negative half is 0. Negative 4 times half is negative 2 plus 0. 5 times half, 5 over 2 minus half, 4 over 2, which is 2. Negative 2 times half is negative 1 plus 0. And now the first row, negative half plus half is 0. Negative half times negative 4 is 2 plus 1, 3. 5 times negative half, negative 5 over 2 minus 6 over 2 or minus 3. Negative 2 times negative half is 1 plus 0 is 1. So what is A inverse now? A inverse is the matrix 3, negative 3, 1, negative 2, 2, negative 1, negative 4, 5, and negative 2. So this is how we find A inverse. You can check now that A times A inverse is the identity matrix, and A inverse times A is the identity matrix. Uh, well, you can do this similarly. So please start by 1 minus 1, 1, 0, 2, negative 1, 2, 3, 0, and write here the identity matrix. And use row operations to change this matrix A to the identity, and then you will get A inverse to the right side. Of course, you can use the same method to find the 2 by 2 matrices, all right? But you have a quick procedure, a quick method to find the inverse of a 2 by 2 matrix. So you use that method. which we discussed in the previous section. You can use this method, but it is longer. So why do you use a longer method? Find A inverse by forming AI and then use row operations to obtain IB. Well, he doesn't have to tell you this one. He just can say find A inverse. So let us find A inverse of this matrix. Now I put a vertical bar and write the identity matrix. This is 1. Use it to make these two numbers zeros. So 2R1 plus R2 and negative R1 plus R3. Okay. R1 is not changing. And we have zeros here. So these columns are not changing. Good. 2 minus 2 is 0. 4 plus 0. Negative 2 plus 1. 2 plus 0. Negative 1 plus 1. Negative 2 plus minus 1. 1 plus 0. Negative 1 plus 0. Good. Now we finished from the first column. Now the second column. Well, I need to divide by 4. To make it 1. 2 over 4 is half. And this is the third row. Now I'll use this one to make 2 and negative 3 zeros. So 3 R2 plus R3 and negative 2 R2 plus R1. R2 is not changing this time. And there is a 0 here, so this column is not changing. And there is a 0 here, so this column is not changing. Let us use this operation. 3 minus 3 is 0. Negative 3 over 4 plus 4 over 4 is 1 over 4. Use the calculator if you like. 3 over 2 minus 2 over 2 is half. 3 over 4 plus 0. Now let us use this operation. Negative 2 R2, negative 2 plus 2 is 0. Negative 2 times negative 1 over 4 is half. Minus 1, negative half. Negative 2 times half is negative 1. Plus 1 is 0. Negative 2 times 1 over 4 is negative half plus 0. Good. Now, this number has to be 1. So I need to multiply row 3 by 4. There is no change. Right now in row 1 or row 2. Row 3 would be 1. 4 times half is 2. 4 times 3 over 4 is 3. 4 times 1 is 4. Now I'll use this one to make these two numbers zeros. So 1 over 4 R3 plus R2 and half R3 plus R1. Now, the third row is not changing. And I have zeros here, so these two columns will not change. All the other columns will change. Okay, 1 over 4 minus 1 over 4 is 0. 1 over 4 times 2, that's half, plus half is 1. 3 over 4 plus 1 over 4 is 1. 4 times 1 over 4 is 1 plus 0, that's 1. Okay, half times 1 plus negative half is 0. Half times 2 is 1 plus 0. Half times 3 is 3 over 2 minus 1 over 2, 2 over 2, which is 1. 4 times half is 2 plus 0, that's 2. So A inverse is the matrix 1, 1, 2, 1, 1, 1, 2, 3, and 4. Please do this one similarly. Write 2, 0, negative 1, 2, 3, negative 2, negative 1, negative 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, and change A to the identity matrix. You will get A inverse here. I'll stop here and continue the next idea in another video.